Okay students, so let's see a few properties on the even and odd functions. If we have a multiplication of two function of t, for example, we have a function ft times with gt. Okay, let's say you have two function, okay, two multiplication of function ft times with gt, so you have two function here. If one of the function ft and gt, okay, if both function ft and gt are even function, therefore when you do a process of multiplication of these two function, what you will get is even function. Okay, if one of the function either ft or gt is odd, okay, so you will get the odd function. Okay, means that if you have ft is even function and you have gt is even function, so what you will get in return when you have do a process of multiplication where ft times with gt, you will get also the even function. Okay, if you have ft is odd function and gt is odd function, okay, you do a process of multiplication for these two function ft and gt, what you will have in return is the function ft gt, where ft gt is even function. Okay, even though when they stand individually they are odd function, but when you multiply two odd functions, you will get even function in return. Okay, but if you have either one of them is even and either one of them is odd, let's say you have ft is odd function, okay, and you have gt is even function, so when you do a multiplication of odd and even function, what you will get in return is odd function. Okay, so when you do multiplication of ft times with gt, so what you will get in return is odd function. Okay, so it's easy to remember when both of them is the same function, even times with even, you will get even, odd times with odd, you will get even. But if there are the different function, even time with odd, what you will get in return is odd function. Okay, so let's see example here. Okay, if you are given ft equal to 2t square cos 3t, so you can see in this function you have two function of t. The first function of t that you have here is 2t square, and the second function of t that you have in this equation is cos 3t. Okay, so this one is your first function. Let's say we denote it as ft, and this one is the second function. Let's say we denote it as gt. So let's check ft is even or odd, gt is even or odd. Then we can conclude our ft is either even or odd. Okay, so let's check. So now what you have is ft equal to 2t squared. So f negative t will give you 2 negative t squared. So what you will get in return is 2t squared back. So now you can show that f negative t is actually equal to ft, means your ft here is even function. So let's check on gt. So you have now your gt is equal to cos 3t. Okay, so when your g negative t, what you will have is cos 3 negative t. So you will have cos negative 3t, whereby trigonometric identities cos negative is equal to cos positive. So this one is equal to cos 3t. So you can see that your g negative t is equal to gt. Therefore, gt also even function. So when even function multiply with even function, so your ft here is also even function. Okay, so let's check the second function ft equal to t to the power of 7 sine 2t is either even, odd, or neither even nor odd. Okay, so now we have two function of t. The first one is t to the power of 7 and the second one is sine 2t. Okay, so let's say we have ft equal to t to the power of 7. Okay, so your f negative t is equal to negative t to the power of 7. So it's equal to negative t. Okay, so your f negative t is not equal to ft, but your f negative t is equal to negative ft. Means that your function f here is odd function. So this one is odd function. Okay, then we have gt is equal to sine 2t. Okay, so we have g negative t is equal to sine 2 times negative t. So what you have here is sine negative 2t, okay, where sine negative 2t is equal to negative sine 2t. Okay, so you don't get g negative t equal to gt because your gt is positive sine 2t. But you get here g negative t is equal to negative gt. Means that our function gt now is odd function. So you have the function t to the power of 7 is odd function multiplied with sine 2t also odd function. So odd multiplied with odd will give you in return the even function. Okay, so let's see the equation number 3 here. So we have ft equal to t to the power of 4 sine 40. So let's check whether our function here is even, odd, or neither even nor odd. Okay, so now you have the first function as t to the power of 4. This one your ft, let's say. And this one our second function sine 40, let's say we do not need as gt. So let's check them individually. So let's take our ft equal to t to the power of 4. So we have f negative t equal to negative t to the power of 4. So we have f negative t is equal to t to the power of 4, where f negative t is equal to ft. Means that our first function here is even function. Okay, then we have gt equal to sine 40. Therefore, we will have g negative t is equal to sine 4 times negative t. So what you will have is sine negative 40, where sine negative 40 is equal to negative sine 40. So you don't have the g negative t here equal to the gt, because gt is the positive function here. But you have here g negative t is equal to negative gt, means your function here is odd function. So you have your ft even function multiply with gt is odd function. So when even multiply with odd will give you the odd function. So your function ft equal to t to the power of 4 sine 40 is odd function. So this one is the properties of even and odd function that you need to remember. Okay, when you have two function where both of them are even, then you will get in return the even function. Okay, when you have your two function where both of them are odd, so the multiplication of that two function will give you even function. But if you have one of the function is odd and another one is even function, so the multiplication of that two function will give you odd function. Okay, so now we want to see on the integral of even and odd function. If you can remember, when we do an integrations or application of integrations, whenever we are integrating the function ft, okay, what we will get in return is the area under the curve. For example, if you have your function ft equal to t square here, okay, when you do integration of t square from negative alpha, let's say this one is negative alpha and alpha, so what you will have is the area under the curve, which is this one, okay, this area, okay, and also the second area is here, which bounded by the alpha and also the x-axis. Okay, so if you can see here, for your even function, you actually get two equal area, okay, where the first area is this one and the second area is this one. Okay, you get the two equal area, because your even function is the function that's symmetric at vertical axis. So what you will get in right hand side, you will get the same on the left hand side. Okay, so when we have the integrals from negative alpha to alpha of the function ft, okay, where ft is even function, actually you can write your integrals here as 2 times with the integrals from 0, means that we are finding only one area, we times it with 2 because it's equal. Okay, so we will find the area from 0 to alpha. Okay, 0 to alpha, your function ft dt. So this one is the other way to write your integrals when it involves the integration of even function, okay, where you can find the half the half integrals and you times it with 2 because they will give the same value, okay, for both sides. That one is for even function. If we have the odd function, where odd function is symmetric about origin, okay, let's say the function of t to the power of 3, when you sketch, you will get this kind of curve. Okay, you also got the two same area, where the first area is here, okay, and the second area is here. When you do an integration, okay, when you do integration of your function ft, where your function ft, okay, where your function ft is odd function, okay, but you need to remember that whenever the area is below the x-axis, okay, so what you will get is the negative value. Let's say this one is 2, you will get this one is negative 2. So where you adding these two area, what you will get in return is 0. Okay, means that if you are integrate, or if your integrals is involve the odd function, where you need to integrate from negative alpha to alpha of the function ft, where function ft is odd function, what you will get in return is equal to 0. Okay, means that if you are doing an integration of a function, you can check whether that function is even or odd. If the function is odd, means that the value of that function's integrals of that function is equal to 0. While if your function is even, you can write your integral as 2 times with 0 to alpha, right, which is half of the range ft dt, the function ft, with respect to t. Okay, so let's see example. For example, if you have to find the integrals, okay, of negative 2 to 2 function t to the power of 3 tan t dt, for example, okay, so you can check whether your function t to the power of 3 tan t is odd or even function. And here you can see it's involved two different functions. The first function is t to the power of 3, and the second function is tan t. So we need to use the properties of even and odd function just now. Let's say we get the first function, we let our first function ft equal to t to the power of 3. So f negative t will give you negative t to the power of 3. Therefore, this function is odd function. Okay, so your first function here is odd. Then you have tan t, where tan t is equal to sin t over cos t. Okay, let's say your gt. Therefore, you will have your g negative t is equal to sin negative t over cos negative t. Okay, so sin negative t is equal to negative sin t, and cos negative t is equal to positive cos t. So what you get in return here is negative gt. Therefore, your function here is also odd function. So when you have odd function times with odd function, what you have here is the integration of negative 2 to 2 of your even function dt. Okay, means that your integrals here can also be written in the form of 2 integrate from 0 to 2. Your range here is divide by 2. You have negative 2 to 2. Okay, you have negative 2 to 2. So now you only need to integrate halfway from 0 to 2. Okay, so from 0 to 2, your function t to the power of 3 tan t dt. So you just need to do these integrals. Okay, so this one is the way on how to write your integrals when it's involved the integration of even function. Okay, let's say we have odd function. For example, okay, let's say we have to integrate odd function. For example, let's say I have the function, I have to integrate from negative pi to pi t to the power of 4 sec t dt. Okay, so now you have two functions here. The first function is t to the power of 4, and the second function is sec t dt. Okay, sec t. So you need to check whether t4 sec t is odd or even, so that you can decide on the integrals. So let's check one by one. So now you have ft is equal to t to the power of 4. So you will have f negative t equal to negative t to the power of 4. So you will get t to the power of 4 back. So your f negative t now is equal to your ft, means that your first function here is even function. So this one is even function. So let's check on the second function. You have gt equal to sec t. Okay, sec is equal to 1 over cos. So you have gt is equal to 1 over cos t. Okay, therefore you have g negative t is equal to 1 over cos negative t, where cos negative t is equal to cos t. So you have g negative t is equal to 1 over cos t. So you get back your gt. Okay, so your g negative t is equal to sec t, where you get back your gt. So this one also even function. So when even function times with even function, you get your t4 sec t is even function. So when you have even function, means that you can break or you can write your integrals as 2 integration halfway. Now you are integrate from negative pi to pi, but now when you want to break it into 2 integrals, so you only need to integrate from 0 to pi. 0 to pi, t to the power of 4 sec t dt. So this one is how you can write your integrals here. Okay, and you just need to solve this integral to get the solutions. Okay, let's say we have another example. Okay, we have to integrate from negative pi to pi a function t square cot t dt, for example. So now you have two functions. The first function is t square, the second function is cot t. You want to check whether this whole function is even, odd, or neither. Okay, so let's check one by one, because this one is a multiplication of two functions. So let's say we have our ft equal to t to the power of 2. So your f negative t will give you negative t to the power of 2. You will get back t to the power of 2. So now your f negative t is equal to ft. Therefore this one is even function. So you have even function for the you have even function for your first function here. So now let's check the second function, where we have gt is equal to cot t. And if you can remember, cot is equal to tan. Cot is equal to 1 over tan. So your gt is equal to 1 over tan t. And your tan is equal to sine over cos. Therefore 1 over sine over cos is equal to cos over sine. So you have gt equal to cos t over sine t, because here you will have 1 over tan is equal to sine t over cos t. Okay, so you will get cos t over sine t. So now when we substitute our t with negative t, your g negative t will give you cos negative t over sine negative t. Therefore what you will have here is cos t over negative sine t, which give you negative cot t. Okay, so what you have here for your g negative t is equal to negative gt. Okay, means that your gt here is odd function. So you have your second function here is odd. So when you have even function times with odd function, means that the whole of this function is odd. Okay, so when you have odd function, what you have for the integrals of odd function is 0. This is the solution of integrals when it involves odd function. Okay, so this is how you can represent your integrals when it's involved either even or odd function.